Good afternoon, everyone. My name is Nick Rook. Today I'm going to be giving a speech on the science behind weather forecasting. So, think about when you wake up in the morning, turn on the news, and you see that 7-day weather outlook. 40% chance of rain on Sunday, 30% chance of rain on Wednesday. It's going to be sunny every other day. Where do you think we get that information from? Think about when you and your family, you and your friends are going to go to the beach. All of a sudden, clouds and whatnot start to form, and within the hour, it starts to downpour. We know all too much about that living in Florida. Trinity Iwicki said herself, living with unpredictable weather isn't easy. It can affect work schedules and class schedules. It can put cars, apartments, and dorms at risk if the weather is severe enough. Typically, severe weather in Florida is high winds, hurricanes, some tornadoes, especially in the last hurricane we just had, many tornadoes. So, what is weather and what causes it? Weather, in short, can be defined as the short-term state of the atmosphere at a specific location and time. This can drastically change from place to place based on temperature, atmospheric pressure, humidity, or wind speed. Obviously, there are many other factors that go into depicting the weather, but these are just some of the main, more broad terms used. For example, think about Florida. It's 85 and sunny right now, but if you head 15 hours north, it's going to be cold, super cold. That is the change, unpredictability of weather. Many variables can influence the weather, like temperature. The variables that can influence these factors can be ocean currents, the season, jet streams. These are all things that, like I said earlier, talking about the temperature and stuff, the ocean currents, the season, jet streams, all of those influence that. So all of those blend into weather. Who are the people who study these things? The people who study the weather in general are called meteorologists. Meteorologist is a very broad term for people who have a career in the field of weather. There are various jobs under the umbrella of meteorology, including forensic meteorologists, professors at college teaching meteorology, atmospheric researchers, meteorological software developers, and most commonly, what everybody thinks of when they think of meteorologists is the people on the news pointing at, it's going to be 40% chance of rain on Sunday. In my opinion, the most looked out or niche field under the meteorology umbrella is a forensic meteorologist. Forensic meteorologists generally are not just crime, but mainly with accidents and whatnot. If somebody was driving and they rear-ended somebody, say they said the sun was in their eyes, forensic meteorologists will go look at the conditions on that day, see which way they're driving, and see if they're telling the truth or not. Okay, according to the American Meteorological Society, forensic meteorologists retrieve and analyze archived weather record information such as surface observations, radar, satellite, river information, and reconstruct the weather conditions for the location in question. The meteorological software developers is something I have personal experience with. Recently, I took a trip to NASA with one of the launch meteorologists out there, and he was talking to me about some of the software that they use and some new software that some of the meteorological software developers are creating. So, the field is ever changing. Lots of different instruments, machines, data is all used to forecast meteorology and the weather, such as weather stations, wind towers, satellites, weather buoys, and radar systems. Living so close to the water in Florida, weather buoys and wind stations, such as satellites, are crucial in depicting the weather conditions conducive for tropical storms or hurricanes, most commonly associated with us. According to NOAA, there are over 1,344 weather buoys deployed in the water currently. That being, I think I counted a little over 110 just off the coast of Florida itself. So now I'm going to talk about what each instrument is and what it does. Weather stations are ground-based, typically monitor local weather. So some weather stations are wind towers, seeing how windy it is in the local area. And satellites, such as NOAA's GOES-19, gives views from space, giving meteorologists a better look at what's happening around us. For example, think about the images you see when you see hurricanes and stuff, all the way up there from space. Meteorologists use the satellites to see different wind currents, jet streams that we couldn't see from the ground. Weather buoys are typically located in the ocean, but can be located in like intercoastal rivers and usually monitor sea temps and the atmosphere. Radar systems like NOAA's NEXRAD give us a live depiction of precipitation and storms. If you didn't know, precipitation is rain and whatnot. Radars are probably most associated with the general public and what weather is. Think about when you open your phone and you want to see if it's going to be raining or not, and you see the colorful map. That's what a radar is. After discussing different methods of weather data collection, it's clear that each source plays a vital role in building our understanding of atmospheric conditions. Now, as we wrap up, let's reflect on how this intricate process shapes the forecast we rely on every single day. The world of weather is constantly changing around us, and meteorologists are constantly changing the tactics used to forecast for us. In closing, the science behind weather forecasting is a blend of technology, data, and human expertise. From satellites capturing global patterns to advanced computer models depicting future conditions, every element works together to keep us informed and prepared. As we continue to advance in the field, our ability to understand and predict the weather not only will improve, enhancing our resilience against the forces of nature. Thank you for joining me in this journey into the science of weather forecasting. Thank you for your time.